Today we will see IP routing. Now this IP routing refers to the process of selecting the shortest and the most reliable path intelligently over which it sends data to its ultimate destination. This a router is configured to work as a gateway device in computer networks. So mostly routers do what? They configured to work as a gateway device, gateway to go from one network to other network. Like you are having your LAN network and you're working in your LAN network. Now you want to go outside of your LAN network, so you will go through the gate, and that gate is called router. It is work like a gateway to the other networks. So a router can be a specialized device supporting multiple interfaces connected to a different network. The routing process usually forwards packets on the basis of routing tables, which maintains a record of the routes to various network destinations. Thus, constructing routing tables which are held in the router's memory is very important for efficient routing, and most routing algorithms use only one network path at a time, and that is multipath routing techniques enable the use of multiple alternative paths. So the router will do what? They will try to find the shortest path for the destination. Now maybe your destination is far, or maybe you are having multiple paths to go from the destination to the destination. So the router's job is to find a proper or shortest path for your destination, and that means what? From one network, from your network to the other network, or maybe in the other side of your office, or maybe in the other side of country, other side of continent. So router's job is to find a shortest path through those WAN networks. So it is router's job is to just forward the packet to the way where it can reach shortly or quickly to the destination. Packet means your data. Now routing in simple terms is the process of sending packet from one logical network to another. That's shown in below like this. As you can see in the image, this is like one network where we are having this one PC which is having a IP of 10.1.1.2, and it is in the network of 10, and the other network is in other side like 11.0.0.0, and there is one machine there like 11.1.1.2. So the router's job is to forward the packet from this network to that network. Now if a router wants to route a packet from source to destination, then it should have the following information. That means this router needs to have the information to forward the packet from this network to another network. First, it needs the destination address. Destination address, that means what? When your packet going from one machine to other machine, like for if the packet is going from this machine, the machine IP is a 10.1.1.2, and it is going to this machine which is 10.11.1.1.2. That means this machine will be called as a source, which is sending the packet, and the machine which is going to have a packet or going to receive the packet, it will be called as a destination machine. So when your router wants to send a packet to a particular network or particular IP, it needs to get the destination address. So it needs what? The destination address to do this. Then it needs to know the neighboring routers which will provide the information about remote networks. That means sometime it is not like this, like all the networks are directly connected to that router. Now in this image, if you see, this network 10 and network 11 both are connected to the same router. So both networks information will be available on this router. This router will know that in my this interface there is a 10 network, and in my this interface I have 11 network. So it can know the information, like if you want to send the packet to any 11 network, he know that he will send it to this interface, and the network will it will reach to that machine. And if he wants to send the packet to the 10 network, then it will send it to this interface and it will reach to the destination machine. But every time it will not be like this. Mostly your router is connected to another router, and that router will be connected to another router, and then so on. And the network which we want to send the data, the destination network, might be far away from your router, which your router don't know about it, but it should know that who is the neighboring router which can provide the information about that remote network. That means your router must know that who is the next router which can send this packet to that network. It should know the next router, we can say, who is the next router which can provide the information about the network which we want to send the data. Then total number of routes to all remote networks. So if your router is connected to multiple different networks, so it should know that all those networks are, where those all networks are, like who is the neighboring router which knows all about all the other neighboring, all the other routers, all the other networks. Now there are some terms related with routing. So before going for the routing, we should understand about these terms. First we say routed protocols. Now when we say routed protocol, the routed protocol is a network layer protocol which can be used to send the user data from one network to another. Routed protocol carries user traffic such as email or file transfer, etc. So the routed protocol is the protocol of the network layer of the OSI layer, which is, his job is to send the data from one network to another. For example, IP, IPX, AppleTalk, etc. These IPX and AppleTalks, AppleTalk is used in Apple, and IPX is now no use. Nobody use it. Mostly nowadays we use IP. So when we say this IP is a protocol, and which is what, routed protocol, which is being routed, and it is the protocol which is routed, and it is also called routed protocol. That is why we use TCP/IP. And this IP's job is to provide numbering system, that is what IP addresses, and that numbering system defines the destination address. Then the next term is called routing protocol. After routed protocol, routed, that means the protocol which is being routed, and the routing protocols are used between routers to determine paths and maintain the routing table. And these are the protocol who is doing the routing. Basically they are the protocols which is doing the routing, and it is called routing protocol. And these protocols job is to determine the best path for the destination and maintain into the routing table. These protocols are, for example, RIP, which is a routing information protocol, IGRP, interior gateway routing protocol, OSP, open shortest path first, etc. Now when we say routing table, so what is routing table? So routing table is a table. It is just a table which contains the information about all networks and the path to reach each network. That means it is just a table which contains information about all the networks and the path. The path, that means how you can reach that network. In this routing table can be called as a map of network which router uses for packet forwarding. That means in our routers we have routing table, and in that routing table we have all the information about all the available networks, whether they are connected directly or connected through with some other routers. So how we can reach that network and what are those networks, all these informations are in the routing table, and that is available in the router. And a typical routing table includes what? The destination network, the subnet mask, the matrix, and default gateway. The matrix and default gateway outgoing interface, that means from where you can reach the network, destination network. Without routing table, packet forwarding cannot be done by a router. So if your router does not have any routing table, it will not able to do any routing. Then one more term is there, it is called administrative distance. This administrative distance defines the cost or weight of the routing tables. Now remember, it is called distance, but it is not related to distance. It is just a, we can say it's a cost or weight of the routing protocols. If multiple routes or multiple routing protocols are configured on a router, so you can define which protocol or route to be used for a specific network. That means if we are having a routing protocol, these are the routing protocols: RIP, IGRP, OSPF, EIGRP. These are the routing protocols. So these routing protocols have a defined administrative distance value, and this value does not contain anything about distance. It contains about the weight of that protocol. We can say that how the protocol, how the we can say how much the protocol is reliable, or we can say how much it is reliable and what is the weight of that protocol. And based on that, they have unique number, they have unique value of this. It is called administrative distance. Administrative distance, that is AD value. So it has a unique and predefined values, and what those values are, these are those values. These are those values. For example, if you are having a connected interface, so it is value is 0. Now the value is 0 means what? The less the value is, the more it is reliable, or the weight is more. It is not like higher value is more important. If you are having a less value here in distance value, AD value, that means you are having a more weight, and that means you are really you are very reliable. The protocol is reliable, or the path or the link, we can say, it is reliable. So if you are having a connected interface, or the network which is connected to your router directly, that will have what? The distance value is 0, and 0 means you can't go less than 0. 0 is the last one. So that means what? It is the most reliable path, or it is the most reliable network, we can say, which is connected directly to your router's interface, and that will have a value of 0. Now others, if you use static, it will get 1, the second best. Then you have EIGRP, IGRP, OSPF, RIP, and external IGRP. So these are having 90, 100, 110, and 120, and 170. These are the different values we have. So we'll discuss it about when we configure these protocols again. Then routing types. So there are different routing types we can do. So in practical, there are several routing ways to configure the routing table to include all the networks so that packets can be forwarded. And here are the routing methods. So the first method we have is static routing. This is the first type of routing. It is called static routing. Then we have a default routing. Then we have dynamic routing. Now static routing means what? It is very simple. Static routing is a form of routing that occurs when a router uses a manually configured routing entry. That means the entry of the routing table, we will manually create the routing table. That means it is actually we create the routing table manually. So rather than the information from a dynamic routing traffic, in many cases static routes are manually configured by a network administrator by adding the entries into a routing table. Unlike the dynamic routing, static routes are fixed and do not change if the network is changed or reconfigured. Now both dynamic routing and static routing are usually used on a router to maximize routing efficiency and to provide the backups in the event that dynamic routing information fails to be exchanged. So static routing is what? It is basically manually configured routing. That means we configure the routing table and it will be configured by the administrator manually. Let's see what we can do with this. So this is a design which I have created here, where we have these two networks here. Like we have here a network of 10. We can say this is our LAN network, and then we have another network which is in the other side, which is 20's network. Now we want to connect them. let's for say example, this one is on the other location, so I will say like this one is on Mumbai and this one is on, let's say it is USA. So this office which is we are having here, it is located in Mumbai, this one is located in USA. Now we want to communicate with them. So what we did, we connected the WAN link. We get the WAN link, we get the ISP, we get the lease line from them. Now they did what? They connected our router's interface to here to there. They provided us a public IP of 30.1 in this interface and 30.2 on this interface. And what? They connected them. Now we are not talking about how it is connected here. So what I did, I not have a ISP, so I did what? I directly connect the cable from here to this, and we assume like it is connected from ISP. Now what? Our job is to configure this router to get connected with these other routers, other networks here. Now how is it done? Now in this LAN network, all these machines are connected together by using this local IP. This is the same network IP, that is 10, and they are connected through the switch so they can communicate to each other. So if I open this machine and I go to the desktop, command prompt. Now if I try to ping the other machine from here, I want to check that whether it is connected to 10.2 or not. So I'll give 10.0.0.2. So it is connected. I'm getting the reply, that means it is connected to that network. Is it connected to 10.3? Yes, it is connected. So within the LAN network, all the machines are connected here. Now I will check here. Is it connected to other machines? This is 20.0.0.1. I will check, is it connected to 20.0.0.2? So it is getting the reply, that means it is connected. Is it connected to 20.3? It is connected to 20.3. Now I want to connect them together, like I want to connect from this 20.0.0.1 to this 10.0.0.1. So if I try to ping 10.0.0.1 from this machine, from the other network, I'm not getting any reply. I'm getting timeout because they are different network, they are located in different ways, different areas, and they are not directly connected also, so they cannot connect. So they cannot connect now. So what we did, we connected the WAN link here. Now we have to configure these routers with these IPs. Now in this interface, we will configure it with this IP which is in the same network of this LAN, and in this interface we will configure the IP which is the IP of the LAN which we have here. And then on the WAN interface we are getting the IP from ISP, that this 30 range, and this is a different network IP. So we need a IP on the WAN link for the communicating those WAN links together. So first I will configure the IP addresses and then we will see about the routing. So these IPs of the machines are already configured in the LAN network. Now I will configure the IP on the routers. So for that, first I'll go to this router. So I will start from the beginning. So I will remove the old configurations. Now I'm going to configure it, and I'm going to configure the IP address first. So first I'll go to enable mode, then global configuration mode. Now first what I will do, I will configure the name for the router so that we understand the router is located on which location. So for that I will use host name. It is located in Mumbai, so I will give a name Mumbai. So my router name is now Mumbai. Now first I will configure this fast Ethernet port, that is our LAN port, which is connected to our LAN network. So I'll go to this interface, fast Ethernet 0/0. Command is IP address. To configure the IP address, and the IP I will configure is 0.0.100, which is the same network IP which we are using here in the LAN. Subnet mask 255.0.0.0. Why I'm not using? Because I'm not using a subnetting, so default subnet mask. Then you can see the light here, it is not green because the port is by default shut down, it is disabled. So for enabling it, I will say no shutdown, and you can see the port is now enabled. Now next I will configure this serial interface. Now before configuring the serial interface, I should check that is it a clock rate there or not, because we connected the cable directly. You can check it by just verifying it from the cable. You can check the cable, it is marked on the cable that this is DCE or DTE. But if you can't check the cable, then you can run this command, show controller serial and then serial number, port number, that is 0/0 here, and this is DTE. So here I don't have to configure clock rate, but I have to configure the IP address here. So again I will go to config mode, then interface serial 0/0, the IP address which is I want to configure is 30.0.0.1. It is also class A, so the default subnet mask is this. Now it is also shut down, so I will say no shutdown. Now I said no shutdown, I enable the interface, but still it is not enabled because it is disabled from the other side, from the other router. So from here my configuration is done. I can check show IP interface brief to check the interface configuration, and it is okay. It is up and up, it is up. This one IP is configured, but it is still down because the other side is down. This serial port is still saying down because the other side of the router, other side of the serial port or other side of the cable is not enabled. So when we configure it from the other side, it will enable again. Okay, so here the configuration is done, so I will close this one. Now I will go to this other router. Now here I will configure this router also. So first the host name, let's say I'm giving USA, so that I can identify which router I'm configuring. Then first I will configure the interface, fast Ethernet 0/0. The IP address is which I want is 20.0.0.100 with the default subnet mask, and no shutdown to enable the interface. And this one is now enabled, but the serial is down, so let's configure the serial also. And now first I will check whether it is DCE or DTE. Now one more thing, all the show commands works on privilege mode. That means if you want to run the show command, so you have to go to the privilege mode, then you run the show command, then you come back to the configuration mode. Now if you don't want to do like this, if you don't want to do every time go back to privilege mode, run the show command, then come back to the configuration mode to configure it, then you can do what? You can run show commands from this configuration mode also. That means you don't have to go to the privilege mode to run the show command. You can run the show command directly from the configuration mode, whether you are in the configuration mode or you are in this sub configuration mode. Whether you are in interface configuration mode, line configuration mode, you can run the show commands. Only you will run with do command. That means if I want to see show running configuration, so I will give show running configuration. I don't have to type the whole command. I will use the shortcut show run, but it will not work here because it is configuration mode. So if you want to run this running configuration or show command here, any show command, show running, show startup, show interface, whatever, you can do with you can start with the do. That means instead of typing show run, you will type do show run and it will work. And you can see it is working. Now I want to check the controller information, so I will do this do show. I'm using the shortcut controller serial 0/0. So I'm using the shortcut, and remember here if you want to run the show command, the tab command will not work. That when you tab, it will not complete. So either you type the short form or you type the full form of the command, but tab will not work. Now it is working here, and I'm checking is it DC or DTE. So here it says that this is what DCE, and here we should manage the clock rate. So now I know that. Then I will go to the interface serial 0/0. First I will configure the IP address, which is we have decided it is 30.0.0.2 with the subnet mask of this, and I will enable now. And when I enable this, it will enable from the other side also, and it is now enabled. It is saying up, and soon it will say up for the other side also. You can see it is now going for the green, and it is now become green. So now it is enabled. Now I should manage the clock rate also. So clock rate, you can give any of these clock rate. So I will go no more than and no maximum minimum. I'll go in between 64,000. So the clock rate is also configured, IP address is also configured, name is also configured. So the router is now configured with IP address and name. We can check by show IP interface brief command. So it is now configured. Now when we try to ping this from any of this machine, now as you see, now these machines are connected to the router. This router is connected to this router, and this router is connected to this network. Now when I try to ping, I'm trying to ping it from this machine PC1. I will try to ping 10.2. It is sending the reply, it is connected. That means this machine is connected. If I try to ping 10.3, it is also replying. Now I will try to ping the router. So router is connected through this interface. So I will try to ping that with this IP. This is the IP of this router's interface, which is connected to this LAN. And I'm getting the reply again. That means now we are connected to router also. And is it connected from this side? So let's check it from this side also. So 20.2 is connected. 20.3 is also connected. These three machines, these two machines, these three machines are connected together. Now I'll try to connect the router interface to check whether we are connected to the router also, which is 20.0.0.100. It is also connected. Now I will try to connect this machine from this 20.0.0.1 machine. So if I try to ping now 10.0.0.1, it will still say that we are not connected. It will still say timeout. Now because it is saying timeout, now why it is saying timeout? We know the router is there, and we can go through the router, and router is also connected, but still it is saying timeout. Now because these machines don't know about router, remember the first thing, all your machines in the LAN network must know that there is a router and we can go through that router to get out of this network. That means they are in the network of 10 and they are in the network of 20. So if they wants to get out of these network, they should know that there is a router present there in our network. There is a router and this is the gateway device, and we can go through this router to get out of this network, our own network, to any other network. So by default they don't know about it. So when you configure this, you have to configure every machine, and you have to configure this every machine with the router IP. That means these all machines in your LAN network must know about router. Now how they will know about router? When we configure them, with the default gateway IP. So when we go to the machine IP configuration, we have information here to configure the IP address, subnet mask, and this is what default gateway. So this default gateway is the router's IP. This is the router's interface IP which is connected to this network. So in this network which is connected to this network is the interface this fast ethernet 0/0, and in that interface we have IP 10.0.0.100. So this IP must be known by all the machines in your network, whether you are having 10 machines or 100 machines or 1000 machines. In all those machines you have to configure the gateway. That means they all should know who is the router and from where we can go out, and what is the gateway, who is the gateway of our network. So I configured this default gateway in this machine, same as I will configure here in this machine. And also I will configure it here in this machine. So remember, default gateway is important and you have to configure it for every machine. Now in this network we have these three machines and their default gateway is this IP, is this interface. So I will configure that here, 20.0.0.100. And on this machine also 20.0.0.100. Now all these machine knows who is the gateway and where they can go out from this network. Now what happened when I ping now? Now when I try to connect the other machine or other network, you saw previously it was saying timeout, complete timeout, because our machine don't know that where is the gateway and we can go from where. Now our machines knows about the gateway. Now when I ping, now we will see a different error. it is still not connecting, it is showing a different error. Now what is the error it is showing? Now this time it is showing the error and it is saying reply, it is coming the reply, it is actually reply is coming. And what it is the reply? The reply is coming from not the IP which I ping this IP. The reply is coming from this IP 20.0.0.100. And what is this IP? Which is this IP? This IP is of the router IP for this network, and that is what this fast Ethernet 0/0, and the IP is 20.0.0.100. And what it is saying here, it is saying destination host unreachable. Now that means what? The router does not know about anything, not anything about this network. So it is saying destination host unreachable because the router does not know anything about this network, and because that network is not connected to our router. If you can see here, in this router we have two networks connected. From fast Ethernet 0/0 there is a network 20 connected, and from serial interface the 30 network is connected, but network 10, this network is not connected to this router. So this router don't know about anything of this network 10, and that is why it is saying what? Destination host unreachable. Same as this machine will say, this will do also. Like if I try to ping it from here, any machine of 20, instead they know the gateway, but still they cannot go there, and we will get the reply from our router saying what? Destination host unreachable. So how it works actually? So actually what happens when you ping any IP from your machine, like we are having these, two machines connected through the switch, and suppose this machine IP is 10.0.0.0.1, and this machine IP is 10.0.0.2. Now because they are class A, so their subnet mask is 255.0.0.0. that means it says the first part is a network part and the rest is what? The host part. So when we ping any machine, suppose I am pinging this machine from this machine. So what happened? When we give ping command, and when we say I want to ping this IP 10.0.0.2, so when I say this, so this machine will check what is my IP. It says my IP is 10.0.0.1, and what is my network? So it says my network is what? 255.0.0.0. that means this is the network, this is the network part, and this is what? This is my network. So it checks its own network first. So when you ping any machine from your machine, so your machine will check first its own network. And what is it? It is saying 10. It is saying 10. Now it checks which IP I am pinging. It is pinging this IP. Now it says whether the network part is same on this IP or not. So when you ping any IP from your machine, so your machine first checks its own network. So it is class A, first part is network, and network is 10. So its own network is 10, and the IP which is it wants to ping, it's also 10. Now that means what? Our machine says this IP belongs to my own network and I don't have to find it anywhere else. So it will try to find it in within the network. It will not try to find it anywhere else. Now if you try to ping any other network IP from your machine, let's say for example we try to ping 20.0.0.2. Now what? Your machine checks that what is my network. So it says my network is 10. And what is the network I try to ping? Now it is saying 20. Is it same? It says no, it is not same. My network is 10 and the IP which I try to ping is 20. So will I find it in here in my own network? No, it will not ever. It is not possible to find it in the own network. So where could I found it? Now this thing, for this thing, it will search whether I have any gateway or not. That means our machine checks that whether I have any gateway available or not. So if you don't have a gateway IP configured in your machine, now gateway means what? Your router which is connected to the other networks, multiple different networks, and also it is connected to your own network, and the IP which is we configured on this interface, that is the IP, is the gateway IP. So if your machine don't know about the gateway, then what it do? It will directly give you timeout when you try to ping this, and that is what happening when I try to ping it without the gateway. So directly it says no, there is no gateway and I can't do this, I can't go anywhere. Now when you configure the gateway IP, that means when we configure the gateway IP to our machine, now our machine knows that where is the gateway, and that is here, this interface, and that means this router. So when we configure the gateway IP to this machine, then what happened? The machine knows that okay, this is not my network and I cannot find it in my network, so I have to go outside of my network, and for that I know the gateway. So what it do actually, it sends the request to the router through this interface, and that is why we need this interface IP of same network. So it sends the interface, it sends the request, ping request or data to this router. It says you are the gateway and you don't know and you know anything about this network. Do you know anything about this 20 network? So it is like asking this router that do you know anything about this network, because it is not our this is not my network. So can you go or can you send this packet to this network, and can you know and do you know about this network? Now the router will do what? The router will check its own IP routing table. It will check its own routing table. Remember, routing table has information about all the available networks and how we can reach to that network. That means the path of that network. So in the routing table, it is written in the routing table that this network we can go from here, this network we can go from here, this network we can go from here. So in this routing table it is written like for 20 network you will go from this interface, for 40 networks we will go for this interface, for 160 network you will go from this network, from this interface. So in the routing table it is written like this, that for 20's network you will go from this port 1, serial 1, like this one. For 40 network you will go from serial 2, for example this, and for 50 network or 60 you will go from this interface. Now it knows the information and it is have in the routing table. Now if it is not in the routing table, if it is not having any information, then it will get the reply to the machine. It says the reply, send the reply to the machine and say destination host unreachable, I don't know anything about the network and I can't send your packet. But if it is knows the network, that means if the routing table is there in the router, then what the router will do, it will forward the packet to that interface, to that path. So because it is 20, so it will send into this interface, it will send into this direction, this path, and then it will go on to reach to other router, or that router will check, maybe it will go to other router, then this router will check whether it knows the information about that network or not. So it will check its own routing table, then it will forward it according to that routing table too, and maybe there is another router which is connected to that router. These are like neighboring routers. So it is sending the data to their neighboring router, this one sending the data to the neighboring router. Now maybe this router has their network connected, so it can send the data to that network, and then it will reach to that machine. So all these routers do what? Forward the data to the path or to the direction from the neighboring router, and by using their own routing table. Now creating this routing table, the process of creating the routing table, it is called the routing. So basically the process of creating this routing table is called routing, IP routing. And static routing means we create this routing table manually. We create it manually. And when you say dynamic routing, that means the routing table will be created automatically. That means the routing table will be created automatically by a protocol which is routing protocol. So these are the routing protocols. The routing protocols are like RIP, IGRP, EIGRP, OSPF. So we will use the protocol, and the protocol will create the routing table automatically, and that is why it is called dynamic routing. So we don't have to care about the routing table. That routing protocol is designed to create the routing table and designed to choose the shortest path, and they will do it automatically and dynamically. So it is called dynamic routing when we use those protocols, and when we don't use any protocol, we configure it manually, it is called static routing. Now how we will configure it in our network? So we will configure it here in our network. So first requirement is the IP address must be configured properly on the router's interface. The second thing, the default gateway. All the machines in your LAN network must be configured with the proper default gateway. Then we will configure the routing here in this router. Remember, static routing means creating the routing table manually. Now there is no routing table, and that is why when you try to ping it, it says destination host unreachable. So because it is not there, and when I try to ping this IP, the router says, it is actually the reply is coming from the router. You can see the IP address of the router, which is this interface IP. So it is saying that I'm not able to reach it because I don't know anything about the router. So by default in the routing table of the router does not have anything. It actually knows the connected network. Basically it knows only the connected network. So right now in this router, in the routing table we have only two network that is connected to the router directly. From the fast Ethernet 0/0 we have connected network 10, and from serial interface we have connected network 30, and that is the only network it knows about. Any other network we have to configure it manually when we configure static routing. So let's see how we can configure that. So for that I will click on the router and I will go to the CLI of router. Now first, to check the routing table. So if we want to check the routing table, current routing table, what are the entries we have in the routing table of this router Mumbai? So we will give command show IP route. This show IP route command will show you the current routing table. Remember, there is no network known. It is not we have not done anything. We have not done any static or dynamic routing. It is only the connected network it knows. So when I click enter, now here it is showing the routing table. What it is saying here is that first it is mentioning some codes. It is mentioning some codes, and these codes are like C. Here it is showing the known networks. You can see one network per line, and it is talking about two network it knows. And how it knows? It knows by this code C. Now C means what? Here you can see C is connected. So these two networks are connected to this router directly, and that is why it knows about this network. It knows about this 10 network because it is directly connected from fast Ethernet 0/0. It knows about this 30 network because it is directly connected from serial 0/0. Now it does not know anything about any other network. Now what is that other network? Other network is this one, USA LAN network, which is 20, and that network is not known in this Mumbai router because it is not connected directly. It is connected to this neighboring router. So if we want to send the data from this network to this network, then this router must know about this network. So for that we will configure the routing table. So this is the current routing table which knows only two network. The third network which we have, it does not know about it. So we are going to create an entry, and we are going to create an entry of statically. So how we'll do that? We'll go to the configure mode, and the command for configuring the routing, static routing, is IP route. IP route, and then when I give a question mark, it says give me the destination prefix. That means what is your destination network. Remember, it is talking about network IP. It is not talking about an IP. It is talking about the network. So the destination network which I want to inform this router is this network 20. So I will mention the network is 20.0.0. This is what a network IP. It is not an IP. Now it will ask what is the subnet mask. What is the destination prefix mask? That means what is the subnet mask of that network. Now why it is asking about the subnet mask? Because maybe you have done the subnetting. So maybe if you have done the subnetting, then you can mention a proper network and proper subnet mask. But right now it is not having a subnetting. I'm not using a subnetting here. I'm using a very simple IPs here because we are not getting into subnetting here. We want to see the routing. So I'm not getting confused. I'm not making you confused by using a complex subnetted IP. I'm using simple network IPs 10, 20, 30. So 20 subnet mask is default because we are not using subnetting here. Now after this, I want to inform, we have to inform the router that where you can go from here, like send the forwarding routes address. Now forwarding routes address means we can say first hop address. We can also say first hop address. Now hop means jump. Now jump means jump from one router to next router. So when your data jump from one router to the next router, we say it is a hop. Hop 1. And this is the first hop. So it is asking that where is that first hop and what is the IP of that first hop. So if you are sitting on this network, then so you are sitting on this router which is connected to this network, and now we want to go to this network 20. We are mentioning the network 20. That means we want to go to network 20. So which interface we can go? So we can go from this serial interface, and when we go from this serial interface, we will reach to this router USA. We will reach to this router USA. So this is our first hop router. This is our first hop router for this network 20 network, and it is asking what is the first hop address. That means when I go from this link, so for entering into this router, I can enter it from this interface, that is what, serial 0/0. I cannot enter it from fast Ethernet 0/0. I can enter it from serial 0/0 because I'm coming from this side. So if I'm coming from this side, I will enter it from this serial interface. And in this serial interface, what is the IP? So IP is this 30.0.0.2. So here you will mention the first hop address, and that is what, your destination forwarding router's address. That is what in our case is 30.0.0.2. Now remember, here I'm not mentioning the network address, I'm mentioning what, a specific IP address. It is like when you see this design, it is like if you want to go to the 20 network, so you will go through this router. So this is your first hop, and this interface is the first router, first hop interface, and that is, you will mention this IP of this interface. Now if you want to go to this network, so that means what, you cannot go with this interface, you cannot go from here, you have to choose the other path. So that for that you will mention the other hop address which is connected to other router. So for this network, when we configure, you will mention this interface, the first hop address IP. And for this interface, for this IP, for this network, maybe it is going from other side connected to some other router, and this will be the first hop router. So for this, when you configure this network in this router, so you will mention what, first hop address as a this interface IP, because this is the first hop address. Now for that, your router will know that if you want to go to 20, then you can go from here, this is the neighbor. If you want to go to 40, then you can go from here, and this is the neighbor. And if you want to go to 60, then you can go from here, this is the neighbor. So always we mention the first hop address which is directly next to our router, and first hop address, that entry address, entry point, like which interface, the entry interface where you are entering into the router, and on that interface whatever the IP is, you will mention that IP, and you will mention exact IP, not a network address. Maybe if you confuse when you mention the network address, that means maybe if this interface is having an IP of 30.0.0.1 and this interface maybe have IP 30.0.0.2, maybe you have done subnetting, so IP will remain same, network will be same 30 maybe. So if you mention only network, then it can get confused, like for 20 network again go for 30, 40 network again go for 30, 60 network again go for 30, and where 30? So 30 is everywhere, it is here also, it is here also, it is here also. So this router can get confused that where I can go for this 20 network, because all these interface are 30. That is why we specify the specific IP address 30.1 or 30.2 or 30.3. So when you mention the first hop address, you mention a specific IP address, not a network address. But when we talk about network, then we mention the network address. Which subnet mask, then we mention the first hop address. And then we will put enter. Now in our network, do we need any other network? Do we need to mention any other network? We don't need to mention any other network because we have only these network. We have 10, 30 and 20. Now this router knows about 10, 30 and 20. I inform to this router. So this router knows about 10 and 30 and 20. I informed it. And now this router knows all the networks available. So now if we check show IP route command, now it says it was connected directly to 10 through the fast Ethernet, and also it is connected directly to 30 with this serial interface. Now it knows about this 20 and it can go via 30.0.0.2. And what is the code here? It is saying S, and that S means what? If you look for the code here, it says is static. That means this route, it knows this route via static configuration. That means via static routing. And we did what? Static routing, we did manually configured it. So it knows about this network by static configuration. Now this router knows about the information, but the other router still does not know about the information. Like this router now knows where is the 20 network, but this router does not know about this 10 network. That means when you send the packet from this machine to this machine, so it will reach there. That means it will go from this machine to router. Now router say, okay, I know where is 20, so it will forward the packet to this router. Now this router says, I know where is 20, so it will forward the packet to this router, this machine. So the packet will reach there. But when this machine sends the reply, so again it will send it to the gateway, and that is what this router. And now this router don't know about 10. So it will say timeout. It will say, no, I don't know about it. So we have to configure this router also, and this router also we have to configure with this 10 network, because in this router the connected networks are 30 and 20. We can verify by checking the routing table, current routing table of this USA router. So when you go to the USA router and we say show IP route, you can say that it is connected with these two networks, 20 and 30. 20 by fast Ethernet and 30 by serial. But it don't know about 10 network. It don't know anything about network 10. So what we have to do here in this router, because we are doing the static routing, we have to configure, we have to inform this router about network 10 manually, and we have to add the entry into this routing table. And how we will do this? We will do it by using config mode IP route command. So again, IP route, the network which I want to inform to this router is 10. What is the subnet mask? 255.0.0.0. Now in this case, what is the first hop address? So because now I am sitting on this router and I want to go to this router. So for that, if I start my journey from here, I will go from this wire and I will reach to this router. This is the very next router of me from this side, and that is what this Mumbai router. And this routers is my first hop router, and this is the interface. Serial 0/0 is the first interface which I can enter into this router. And what is the IP of this interface is 30.0.0.1. So this is my first hop address. So this will be my first hop address for this network 10. So what I will mention here, 30.0.0.1 and enter. Now we don't have any other network, The 20 and 30 it's already knows. 10 I informed. We don't have any other network, we have only 10, 20 and 30. Now I will check show IP route. Now here it already knows about these two networks because they are directly connected to this router, that is C. And now I configure this S, that is static. I configure this network 10 and via 30.1, and it is going via 30.1. Now when I configured it, now we can check our machines is they can ping or not. Now let's check from this machine whether it can connect these other 20 machines. Now remember, previously it was not connecting. First, when they don't know about the router, they were saying timeout, but when they knows about the router, they are getting the reply from the router is destination host unreachable, because our router don't know about anything about that network 20 from this side. Now we configured this static routing, we informed the router, we created the routing table manually. Now we try to ping again, and now you can see it is getting the reply from 20.0.0.1, which is from the other side of the network and which is connected to the other router. Now why? Because our router now knows about this network. Now we can connect any of those IP 20.1, 20.2, 20.3. You see one more thing here, it is losing one packet. It is losing one packet when you ping first time after doing the routing table, after creating the routing and routing table. When you ping it first time for the other network, you will lose first packet, but after that you will not use any packet. So if I ping again same IP, I will not lose any packet now. Now if I ping this 20.3 first time, it will lose one packet, first packet. Again you see it will lose the first packet. It loses the first packet, but after that it will not lose any packet. Now why it is losing the packet? There is a reason behind it. It loses the first packet because of ARP. It loses the first packet because of ARP, and that how that ARP works. But our routing is done, and now we can see that our machines are connected from this network to this network, and we did it with this static routing. But there are some problems with the static routing also. There is some advantages and there is some disadvantages of this static routing. First, advantages of static routing. Static routing can be used to define an exit point from a router when no other routes are available or necessary. So it is the advantage, like static routing we can use to define any exit point, because we are defining it manually. Remember, we are defining it manually, so we can define any exit point. We can go from anywhere. Like we have seen already that we may have multiple paths from our router, so we can define which path we can choose. Now this is called a default route. Now when you select this any, then it is also called default route. I will show you what is default route also. Now static routing can be used for small networks that require only one or two routes. This is very good. Remember, this static routing is very fast, faster than any other routing which we do, and that is why, remember, that static routing distribute the AD value is 1, because it's very fast and reliable to do. So our router will work very fast and the routing will be very fast, but it can only go for small network, maybe one or two routes. This is often more efficient since a link is not being wasted by exchanging dynamic routing information. So it is more efficient because it is not using any extra overhead of wasting the packages or changing the exchanging the information about routing. When you do the routing, dynamic routing, then there are lots of overhead and it gets very slow. So static routing is often used as a complement to dynamic routing to provide a fail-safe backup in the event that a dynamic route is unavailable. It can also be used as a backup when your dynamic route is failed or not available, then you can use a static routing also. Now static routing is often used to help transfer routing information from one routing protocol to another, that is known as routing redistribution. Also, it is also used to communicate between two different routing protocols. Remember, routing protocols are the RIP, EIGRP, IGRP, OSPF. They can only communicate within their routing, within their same protocol. If you are having one router configured with RIP and other router is configured with IGRP, they will not do the communication because they work differently. So they don't give a communication, they don't communicate with each other, they don't exchange anything. So we can communicate with this static routing manually. We can create the link between those. These are the basic advantages, but there is lots of disadvantages of this static routing. In many cases, static route are manually configured. Basically, we configured it manually, and this increases the potential of human errors. That means because we are configuring it manually, we can make error. We can make a we can type a wrong network. We can type a wrong first hop address, and our router will misguide. So administrators can make mistakes and mistype the network information or configure incorrect routing path by mistake. So static routing is not fault tolerant. Not fault tolerant, this means that when there is a change in the network or failure occurs between two statically defined devices, traffic will not be rerouted. As a result, the network is down until the failure is overcome or the static route is manually configured by an administrator. That means suppose you are having this, this is your network and you are connected to the router. Now you want to reach to this network and maybe it is connected to some other router. Now for going to this router, maybe we have multiple paths. Sometime because it is very far, so maybe we may have multiple paths. Multiple paths, that means we can go from here or even we can go from here. Or even we can go for, let's say, here. Now maybe we are having three different paths. Now when we configure static routing, we configure it manually. Manually, that means I will choose a path. Whether I want to go from here, so I will give this first hop address. If I want to go from here, I will give this first hop address. If I want to go from here, then I will give this first hop address. Now here I will choose the shortest path manually because I am configuring it manually. So if I say from here I will go, if I go from here, I will choose, I have to go through two routers. That means it is a long distance. If I go from here, so I have to pass 1 2 3 routers. That means it is bigger than that one. But if I go from here middle route, then I will have to pass only one router. That means it is the shortest path. So I will choose manually. So I will give this first hop address for that network. That means I am using it manually and I am giving it shortest path. Now it is manually configured. That means it will not change automatically. Now in that case, if this route is down, because we configured it manually here, it will not change automatically. So this network is not available for us until we change the path manually. So because it is not working, so this network will not be available until I change it manually. I remove this path from our routing table by using the simple no IP route command. Then I will add the new path. Maybe I will add this first hop address, but this I have to do it manually. Until it will not change automatically. That is the problem in static. Other hand, if you use dynamic, so dynamic will do what? If one path fails, automatically it will switch to other path if you have other path available. Which is not available, this thing will not be done in static routing. And this is the disadvantage of the static routing also. Then the static routes typically take precedence over routes configured with the dynamic routing protocol. This means that static routes may prevent routing protocols from working as intended. As a solution is to manually modify the administrative distance. Now remember the administrative distance we have talked about. These are the default values which is defined, which says what? Which says about the reliability of the network. So if we configure the static route and also we have configured the dynamic routing also, then the static route will take the precedence and it will not work as you thought it work, because the administrative distance value of the static routing is what? Less than any other routing protocol. If you remember, and how it is done, like if suppose this is the design and what we have configured it like we have configured a RIP here in this protocol. In this router we have configured RIP, and in this router we have configured OSPF, and in this side we configure static routing. We configure static routing for a backup. For a backup, that means if suppose that main network is not available, then automatically the router will take this static path. So I configure it statically here, this path. Now the problem is what? This static routing's administrative value is less than any of the protocol. Remember, static routing protocol, static routing route AD value is 1 and RIP value is what? 120. If you configure OSPF, it is 110, and if you configure EIGRP, it is 90, IGRP 100. So when your router decides that which path to take, when this router decides that which path to take, then it check the AD value first. First it checks the AD value. So RIP says I have RIP in this router, it says I have 120 because it is RIP, and this one says it is 110, which is 1110. Now within these two paths, what is the minimum? Minimum is this 1110. So it can take this path. That is what I want. It should take this path. But the problem is this, I have already configured static also. Now static path AD value is 1. So our router will do what? It will not choose this path. It will not choose even this path also. And it will always choose what? This path. Which I don't want. I want it always choose this path. It should not choose this path. I want this, that only if this path fails, then it should go for this path, because you see this path is short and this path is a long. So I just kept this path for a backup. I don't want this path to be used every time, because if it goes for this path every time, it will get slow, because it is to reach the long distance and this may be a slow network. So I don't want this. But because of the AD value, it will always choose this one. It will not choose this, it will not choose this. Whether it is having a more speed, whether it is having a less distance, the name is administrative distance, but it is not related to distance, it is related to the reliability actually. So if it is 1, that means it is more reliable, so it will always choose this one. So if we don't want like this, then we can change the default behavior. We can change the static routing's AD value also. So when we are configuring the static route, we can also change the value of this AD, administrative distance value of this static route. Example. So for example, when we were configuring the static route here in this router. So we give command IP route, we mention the network, then we mention the subnet mask, then we mention the first hop address. After that, when you give a question mark, you will see that you can mention distance value also. So you can change the default distance value. By default, it uses the distance value is 1. So you can change it to any other value according to your requirement. In that scenario, like in this scenario, I want that it should use this path. It should not use this path and not this path. So what I will do, I will increase the distance value of this static routing, which is more than 120. So this is 120 and this is what 110. So when I configure this path, I will mention, for example, 130. So what happened in these 3 paths, when our router decides which path to choose, so this is 130, it will not choose it. This one, it will not choose it. So which one it will choose? It will choose this one, because the AD value is 130, and that we can do by using that command, by using this IP route command, and when we configuring the IP route for the static routing. So here we can mention like this 130, and it is already configured, but if you want, then you can change the AD value. But it is also like a disadvantage, because we have to do it manually. Then the other disadvantage is like static routes must be configured on each router in the network, and this configuration can take a long time if there are many routers. If it also means that reconfiguration can be slow and inefficient. That means when you are having multiple routers, then you have to configure each and every router, and you have to mention every available network in each and every router, and that can be a very slow configuration. It will take a time and it will be inefficient, or it will be a error. That means you can make a lots of error with this. That means what? Now here what? We have only 2 networks basically. We have only 10 and 20. We want to connect only 10 and 20. This 30 we just used for connecting these router together. So if you have multiple network and multiple routers, then you have to configure each and every router for it. For example, I will add one more network here. Let's say I will add one more network here. So I will add one more network here, for example, so that I will add one router and one switch, and on that switch I will add one one machine. It is just what I want to check the communication. Then I will connect. Okay, this one does not have serial port, so first I will add the serial port here. Okay, now I will connect, and here in the connection you can use the dynamic automatically connection also, so it will connect automatically. You don't have to select. See, it is connecting automatically. So if you want to do it quickly, then you can use this automatic cable also. Okay, so now what I will do here, let's say this router is in UK, so I will mention the name for the router is UK, and this interface, now we have extra interface here. So in this interface I will use, let's say, 40 network, and for that I will use this 40.1 on this interface, 40.2 on this interface, and for serial LAN I will use this 50 network, and this one I will use 50.1. maybe it is, I'm using here network of 50. Okay, so first I will configure the IP addresses. So here it is serial 0/1 and here it is serial 0/0. So first I will configure this IP on the interface because it is now added this interface. So I will go to this interface first. First I will go to this router. USA, show IP interface brief. So this is the interface which is already there. Now we added this one also, we connected, and we decided the IP is 40.1. so I will configure it. Interface serial 0/1, the IP address is 40.0.0.1 with this subnet mask, no shutdown to enable it. And one more thing, it is having a clock rate, so clock rate also I will mention. Now all done here in this interface. So for this, from this interface, this router USA router will connect to this UK router. So on this router, so first I will mention the name for this router will be UK. Then interface serial 0/0, which is this interface, and the IP I'm using is 40.2. so IP address is 40.0.0.2 with this subnet mask, no shutdown, clock rate we have already given. Now I will configure this interface with this IP. So interface fast ethernet 0/0 with the IP address of 50.0.0.1 100 with this subnet mask. Now IP address is configured here. On router also, the router which we added right now. Now this machine I will also configure the IP address so that we can communicate. 1 and gateway will be 100. Okay, now we added extra network, extra router. Now when you have multiple network or multiple router, that means you have to configure every router for it. That means first suppose I add the network here in this first router which we added right now. So I will go to check the routing table first, show IP route, and what it is saying here, it knows only 40 and 50, which is because it is connected. Now what it does not know is 20 and 10, that we have to configure here in this UK router. So we'll go to this IP route. First I will mention 20 with the subnet mask of this. Now what will be the first hop address? So the first hop address will be like if I'm sitting on UK and I want to go to this 20 network, so I can only go from this cable, and the first router is USA, and the interface which I made is serial 0/1, and the IP address of that interface is 40.1. so this will be my first hop address. Now there is one more network which this router don't know, which is 10. So I will mention IP route 10.0.0.0 with this subnet mask. Now what will be the first hop address for 10? Remember we are sitting on 20 and we want to go to this network 10. So where we can go? So we can go from same this link, and what is the first router? This USA. And what is the first interface? This serial 0/1. And what is the first interface IP? Is 40.1. Remember I said first, that means always you will mention the first interface, first router, first hop address. Does not matter your network is on which network or which how far it is and how much routers are in between. It is you don't care about it. You just mention the first hop address. That means we cannot reach to Mumbai without passing the USA. You have to go through this, and this is the first one, and you have to mention always the first hop address. So for 20 is also 40, and for 10 is also 40, and if I have any other router next to this Mumbai, still the first hop will remain this 40.1. so the first hop address will still be 40.1. Now I configure two routes is nodes, and two route I configured manually. Now assume if you are having 10 routers, 10 routes and 20 networks, then you have to mention every network by using the first proper first hop address. Now show IP route. Now it knows all networks, and now it is configured. The new router is configured. Two networks it knows by connected, and two network it knows by statically configuration. Now the problem is not finished. The configuration is not finished here, because we configured this router, we added this one, we configured this one also, but now we have to configure USA and Mumbai also, because now this router does not know about this new network. So when you add new network, you have to configure every network in your design or in your network. So now I have to configure USA also, and I have to inform the USA that there is a new network available, and also I have to configure Mumbai that there is a new network available. So let's first go to the USA, and if I check here, show IP route, so it knows this 10, 20 and 30, and also it knows by the 40. Why? Because it is directly connected to this interface. but still it does not know about 50. So we have to configure it here manually. IP route 50 this mask. Now where we can go from 50 for 50, so we can go for 50 from USA. If you want to go to this 50, we can go from here, and in this time this is the first hop address, which is 40.1. so here I will mention 40.2, 40.1, not 40.1, it is actually 40.2. Now any other network? No. So it is done here. Now it knows all the networks here, 10, 20, 30 and also now 50. But still this router don't know about these new networks. If you see show IP route, it still knows only about 10, 20 and 30. 10 and 30 is directly connected, 20 we configured last time, but 40 and 50 it is not connected to the router and it does not know anything about it. So that we have to configure it manually, and that is what the disadvantage of this static routing. IP route, then I will mention 40 by going from this. In first hop address will be for 40. It is, if I'm going from this side, again it is 30.2. Now for 50, what will be the first hop address? Again it will be same, does not matter where the network is, the first router is always this router. So the first hop address is this. And now it knows all networks, and now we can communicate from here. We can ping from this machine to any other machine in the network. Like we can ping 20.0.0.1 and also we can ping 10.0.0.1. So now this 50 network is also included. Now if I add more networks, then what? I have to configure each and every router again. Then I have to configure Mumbai again, I have to configure USA again, I have to configure UK again. So because is this configuration overhead, and maybe I can make a mistake, I can make wrong network, I can configure wrong first hop address. So we can do configuration, we can do make wrong configurations also. That is the drawback of this static routing, and that is why we use static routing only on small networks, not on a big network, because it is not manageable. And for that we use dynamic routing. So for big networks mostly we use dynamic routing. Now how we can add the route? So this is the syntax of adding the route, which we have done already. Like the command is IP route, then you will mention the destination network. First is this IP route, this is the standard announcement of the static route command. Then destination network is the IP address of the network to include in the routing table. Mask of the network. The next hop address, it is the address of the next hop router that will receive the packet from you and forward them to the desired network. Then you can mention the exit interface also, like you can mention the hop address, or even you can mention the exit interface also. Instead of next hop address, you can declare the exit interface on your router. Sometime you don't know about the exit next hop address sometimes. So what you can do, you can mention the exit interface. That means what? That means suppose you are configuring here in this router and you don't know about the first hop address, so you can mention the exit interface. Exit interface, that means if I want to go to 20 or 50, I can go from this interface, serial 0/0. I cannot go from fast Ethernet 0/0. So this will be my exit interface for these networks. So instead of mentioning the first hop address, I can mention this exit interface. And when you run the command IP root, you can see that that option is also available. You can see when you try to give first hop address, if I give a question mark, then instead of giving the first hop address, we can declare the interface name also. That is your exit interface name. Then the administrative distance, that you can mention administrative distance if you want to change this default administrative distance value. And also you can use the permanent. That means with the permanent word, the router is forced to keep this route in its routing table even if the interface leading to this network is shut down. And under normal circumstances, if this happens, static route involved are automatically removed from the routing table. That means when you mention the exit interface, if you mention that you want to exit from serial 0/0, and if that interface goes down, then what, that static route will automatically remove. But when you give this permanent command there, that means even if the interface is down, still the route will not remove, it will remain there, and whenever the interface comes up, it will use that route. So this is what the static routing, and this is how we can configure. These are the commands, and to verify we can use show IP route command. And this is how we can configure the static routing.